in these examples, a point source moves with the speed v0 towards a concave mirror with the radius r. Find the speed of its image. Okay, so if we have a concave mirror, let's say okay, so we have this concave mirror, and okay, so this is the center of the curvature, right? C, and this is the F. Okay, so now if we have a point source, this point source, the point source is moving towards the concave frame with the constant speed, let's say equal to the v0. So now we just want to find the image, right? We just want to find the speed of the image, I mean due to this point source here. Okay, so one thing that you can see, right? Okay, if you consider this simulation again, you can see that. So when we have the object, right, moving toward the point source, so the image will move to the opposite direction, okay, and the image will be larger and larger as well, until when the object is close to the focal point and then go to the focal point, so the image will be at the infinity, right? So it means that we cannot see the image anymore. But now between the focal point and then, between the focal point and let me refresh again. Okay, so then between the focal point and then the vertex, the image can be found, I mean behind the mirror here. Okay, then so we just want to find the general equation, right? I mean for the speed of the image in this case. So let's just start from this equation: the 1 over the s plus the 1 over the s palm equal to let's say that the 2 over the r. So don't forget that in the case of concave mirror light, the r is positive. Okay, and now this s is going to be the object distance, so it's be this distance. This can be for the s here, and then okay, if the object is here, right, then we know that the image should be somewhere, I don't know, maybe here, should be somewhere here, right? So this is going to be the image distance, the s palm, and then this image is moving to the left hand side with velocity equal to the v. Okay, so then how can we find the speed of the object and the speed of the image from this equation? Okay, so let's see this. To know the v and to know the v0, right, we said that the v and the v0 is just equal to the displacement over the time taken. Okay, then what is the displacement for the v0? So now, okay, when the times delta t, the object can move from this position and then to this position. So it means that this distance, right, is be equal to the delta s, the displacement of the object. Okay, so it means that if we just want to find the v0 in the terms of ds, right, it's going to be equal to ds by dt. Okay, it's just equal to the ds by dt here. Then the same for the v. Okay, the same for the v, for the speed of the image. Okay, if the image move from here and then to the here, then we can get the displacement of the image to be the delta s palm, right? Then again, we can get the speed of the image to be the ds palm by dt. Okay. Then the trick to have the s palm and the s here is that we need to write down this equation as the s palm. depending on the S and the R. Okay, so that's gonna be the idea. Okay, so let's do it. We have the 1 over the S palm, right, equal to the 2 over the R, and then minus the 1 over the S. So we just move this to the right hand side. Okay, so now let's just multiply across here, equal to the 2S minus the R, and then over the R times the S, right? So then finally we have that the S palm equal to the R times the S, and then over the 2S minus the R. So this is going to be the image distance. So now let's take derivative. Okay, we can get that the speed of the image is v, okay, equal to ds by dt. So this one is be the speed of ds palm by dt, sorry, this be the speed of the image, right? Okay, but now you can see that this equation of the S palm, right, it just depends on the S, not the S, not the T. Okay, so let's use the chain rule. We have that the ds palm by ds, and then times the ds by dt. Okay, ds by dt is known already. It's just equal to the v naught, this the speed of the object, right? Okay, so then we have equal to the v naught. So now ds palm by ds, right? Okay, so we need to take the derivative of this function. Okay, respective to the s here. Okay, so let's use, okay, we have the 2s minus the r, so this means the denominator, and then derivative of the numerator, right? So just equal to the r, and then minus the numerator, and then derivative of the denominator, which is equal to 2, and then over the denominator square, right? We have the 2s minus r and then square. Okay, so let's see here. We have the 2s times the r. It's going to cancel out with the 2s times the r here, right? And we have the minus of the r square. So then finally we can get that the speed of the image equal to minus and the r over the 2s minus r square, and then times the v naught, right? So this can be the answers. Okay, one thing that you can notice from this question is that, okay, so let's consider this negative sign. Okay, so now this negative sign, right, it just means that the image just move to the opposite side, right, to the object. Okay, for example, if the object moves to the right hand side, so the image will move to the left hand side here. Okay, and one more thing is that, so let's consider this denominator. You can see that at the 2s over the r, right, so this denominator equal to the 0, so at the 2s equal to the r, or we can say that when the s equal to the r over 2, right, which is equal to what? Which is equal to the focal length of the object. Okay, it means that when the object just move here and then on this position, okay, on the focal point here, so the speed of the image, right, just tend to the negative infinity. Okay, the speed of the image just tend to the negative infinity. Okay, so we can just check this one from this simulation again. Okay, so I have the object here, so you can see that when I move the object to the right hand side, the image will go to the left hand side, right? Okay, so let's see, and then when we just getting close to the focal point, then the speed of the image will be really large, right? And then go to the infinity, because when the object is at the focal point, the object is formed at the infinity, so it means that it's impossible for us to see the image. Okay, so let's add here again. You see, so this the speed of the image just go to the infinity.